This video is part 2 for lesson 5.8, which is on polynomials and several variables. This video is going to look at multiplication. So these multiplying the polynomials that are in several variables is going to be very similar to what we did in previous lessons. Just now we have, again, more variables to account for. So for this first question is number 20 out of the textbook. And with this problem, we're essentially just going to be doing the distributive property. So we have this monomial on the outside of this binomial. And so we're just going to take this negative 4y to the third power and multiply it to both terms inside the parentheses. So what's going to happen, we're going to have negative 4y to the third times 4xy. And then I'm just going to write this as plus negative for now, plus negative 4y to the third times the 15y squared. And so now going through this, again, it goes back to rules for exponents. So that comes into play with a lot of these lessons moving forward. So really make sure that you understand those rules. So using our rules for exponents, we can simplify this. So negative 4 times 4 is negative 16. We're going to put x next since technically we should write our variables in alphabetical. Y to the third times y to the first, we can actually add those exponents and this becomes y to the fourth. And then this is just going to be negative 4 times 15, which is negative 60, so we can write this as minus 60, and then y to the third times y squared, that's going to be y to the fifth. And then this is as far as we can go with this multiplication question because we don't have like terms to combine. Number 22 is going back to when we had a binomial times a binomial. So we're going to follow that same process. And in this question, you can use the FOIL method or think of it as using the distributive property twice. I'm going to go through and think of it as using the distribution property twice, but you can, again, use FOIL if that's what you prefer. So starting off, we're going to be doing x times 3x plus x times 8y plus, then we're going to be doing 7y times 3x plus 7y times 8y. So that's what we get after we do the distribution twice. Or if you did FOIL, you would end up with something very similar, just maybe in a different order. So now we're going to go through and simplify this. So x times 3x is going to give us 3x squared plus this right here is going to become 8xy plus 7y times 3x is going to be 21xy. And then 7 times 8 is 56, and then this will be y squared. And then in this next step, we have one pair of like terms with the xy's. So we're going to combine those for our final answer, which will be 3x squared plus 29xy plus 56y squared. And that's our final answer for this multiplication question. And then for 26, this is again a binomial times a binomial, and this is actually leading towards those special products. So this was back in lesson 5.6. And so in lesson 5.6, they talked about all these special product rules, which is something, again, you don't have to memorize right now. Or I'm sorry, this was lesson 5.5 that it was mentioned. I just went back and reviewed it. So lesson 5.5 is when they talked about the special product rules. And so this one and number 28, which we'll be talking about in just a moment, those are leading back to those product rules. But even if you didn't have those memorized, you can still go through and solve this problem using the same method that we just did on the previous problem, which is to use either the distribution property twice or to use FOIL. It's totally up to you. Again, those rules back in lesson 5.5, like I said earlier in the video, I misspoke. I said 5.6, it's actually 5.5. Those rules will come back into play later, so you do kind of want to start familiarizing yourself with them a little bit, but it's not essential that you memorize them for this chapter because, like I said, we can do the distribution property twice on this, and hopefully we all feel comfortable with that. So we're going to do 3a squared times 3a squared. So we'll start writing that out step by step. We're also going to do 3a squared times b squared, so plus 3a squared times b squared. This right here, this minus b squared, again, this is the same as plus negative b squared. So we're going to have negative b squared times 3a squared plus another negative b squared times b squared. So now we're going to go through and use our rules of exponents to simplify all of this. So 3 times 3 is 9, a squared times a squared will be a to the fourth. This is just going to end up being 3a squared b squared. We can't use any rules there. We just basically put those together. This here is going to become, we can write this as plus negative 3 and then a squared b squared. And then here we'll have plus, and we can write it as negative b to the fourth, since negative 1 times 1 makes a negative 1, which again, you don't need to write the 1 part of it. So combining our like terms, we have this 3a squared and this negative 3a squared b squared. Those are actually going to cancel out. So our final answer for this question is just going to be 9a to the fourth minus b to the fourth. So that's what we get for that multiplication question. For this next example, we have to be careful with this exponent here. Students are often tempted to try to distribute it to both parts that are in the inside here, and that only works if it's a product. This is not a product, it's a sum. So we have to remember that squaring something means you're taking itself and multiplying it by itself again. So this here is 2/5 xy plus 3 times itself again. So if you see a problem like this in the future, make sure you take the time to rewrite it as the two binomials. And now, just like the previous questions, we're going to go through and either use FOIL or the double distribution. Either way, I'm going to go through again and think of it as double distribution. So we're going to do 2/5 xy times the 2/5 xy. So we got 2/5 xy times 2/5 xy. Then we're also going to have 2/5 xy times 3, so plus 2/5 xy times 3, plus, now we're going to do 3 times everything, so 3 times the 2/5 xy, plus, and then we have last is the 3 times 3. Finish drawing our arrow there. So now that we're at this point, we need to go through and again simplify this. So 2/5 times 2/5 will be 4/25. And then this is going to be x squared, y squared, because x times x is x squared, y times y is y squared. Plus, then we're going to have 2/5 times 3, which is 6/5 xy. Plus, we're going to have another 6/5 xy, because again, this is, you can think of as being over 1. So 3 times 2 is 6, 1 times 5 is 5. And then 3 times 3 is 9. Combining our like terms, which in this case are our two fraction terms here, 6/5 xy plus another 6/5 xy, that's going to give us 4/25 x squared y squared plus 12/5 xy plus 9. And that would be our final answer for this problem. And then question number 32 is the last example for this lesson. And with this question, we have a binomial times a trinomial, again, in multiple variables, but the process that we used in the previous lesson with the distribution property is going to apply for this as well, even though there's more than one variable. So we're going to do x times everything first. I'm actually going to go ahead and take the time right now to rewrite this as plus negative 5xy. And so, yeah, it's just a lot of distribution and then simplifying. So starting off, we're going to have x times x squared plus x times this negative 5xy plus this x times the 25y squared. So that's the first distribution. Then we have to go through and do 5y times everything. So 5y times x squared plus 5y times the negative 5xy plus the 5y times 25y squared. So now that we have all of that multiplied out, we need to actually go through and do some of this multiplication and simplify. X times x squared is going to be x cubed, or x to the third power, plus this will be x times negative 5xy is going to be negative 5x squared y, plus this is going to be 25xy squared if we rewrite it in the proper order. This here, again, rewriting it in the proper order will be 5x squared y, plus 5 times 5 is negative 25, and then this will be xy squared. And then, last but not least, 5 times 25 is 125, and then y times the y squared is going to be y cubed. So again, combining like terms, we have an x squared y term here and an x squared y term here. Those two are like terms. The xy squared and the xy squared there are also like terms. And what happens in this problem, similar to a previous example we looked at, all the like terms actually cancel out. So we're going to be left with just x cubed plus 125y cubed as the final answer for this multiplication question.